Okay, this is our video on 100N Condensate 1. How we did an overview the other day of how the different systems kind of tie together. The problem with these systems are very complicated and they're interconnected in a lot of different ways. But Condensate 1, this is pretty much all the condensate coming from the dump condensers and return from Hanford generating project. I would come into Condensate 1 header, broke into 4 sections, had isolation valves each section. Part of this loop I believe is for expansion. It's a pretty long run of pipe. I don't ever know of it being isolated and still running. But basically on Condensate 1 you had your dump condensers. You had there's 16 of them, dump condenser, condensate pumps, there's 16 of them. And you had 3 surge tanks. I believe the standpipes were valved out at this point and they were not used. What I've been told is when the Hanford generating project was added, they added cell 6 and a lot more valving. Usually all the valving that started out with a 6 was added at that point. I think this HPV 62, 63. This would be a block for the pressure control for your 10-inch surge tank header. The surge tank was very complicated with controls. It had to maintain 3 pounds differential pressure between your main steam header on the roof and Condensate 1, which is in the -16, basement of 109. These are also inventory control. You had a lot of water out in this system, like all the return from Hanford generating project, then your drive turbine surface condensers and the turbine generator from 184 all ended up back in this system, plus the dump condensers. So maintaining level was really critical on this. From the main steam header, you had your block valves. These are on the roof. So your dump condenser valves, these are up there on the roof mezzanine. You know, these are run with a hydro pack. These I think might have been manual blocks, I'm not sure. But all these blocks were up on the roof. It came down the mezzanine, then you had your pressure control valves. Your 214s here were 4-inch valves. And like the 6214, they were 6-inch on the ends, so they had to add quite a bit more steam availability to maintain this header when they put the other surge tanks in and started running the Hanford generating project. This pressure got too high. It was dumped through the 234 valves. These were 2.5-inch. The 4 inches were on the outside. So most of these were 2.5-inch valves would dump the steam down to the high pressure return header to maintain the pressure on the system. If the surge tank flooded, you could get water up here and you could lose your pressure control. If it got too low, you get steam down to your condensate pumps. On the Condensate 1 header, you had 16 condensate pumps. They were 100 horse motors. I don't know what the gallon per minute is or the discharge pressure a foot ahead. I really can't find anything on it. But you had hydrazine, morphine could be injected down here. Most of this, I believe, was done from the Hanford generating project. Our steam went over to the called Whips or Hanford generating project. They had 2 turbines, put out about 860 megawatts electrical. The condensate was deaerated. Then it went through a Powdex unit, kind of a demin unit, and then chemicals were added. What could be hydrazine and morphine. They used morphine as needed to maintain pH. O2, you went less than 50 parts per billion max. The ammonia, you went less than 1,000 parts per billion max, or basically 1 ppm. pH 7 to 10, and hydrazine less than 50 parts per billion. Condensate coming back, you had 2 valves, FPDV 6203s. These were somewhat controlled the surge tank. If they got in trouble losing level, these were too high level, these would back off, then keep the water over there to get level under control. The condensate fed back into Condensate 1, which was then pumped back to Condensate 2 and sent to the steam generators In an event of high pressure, the normal steam pressure was about 135 psi. I believe this tripped at 180. If you had a trip of the generators next door, the pressure would shoot up and then it would scram the reactor. Normally they leave a couple of these running hot standby, so in case of load rejection, they pick up the load real fast. Or if these levels started getting really low, these would open up and try and condense more steam and build condensate 1 back up. If the level got too low, you had your MWVs, 203s, 2 of them. These would open, then your afterheat removal pumps in 182 would auto start, and you could feed water in that way. Those pumps had to be manually shut off, but they're really like 2,500 gallons a minute. It also fed the generator in 184 for emergency feed. On the dump condensers, you had your valves on the roof. 202 is a block valve. HPV 201 was a control valve. The steam fed in. These are 18 feet tall. Had 24,706 3/4 inch tubes. Down here would be the water box for the tubes, or U-shaped tubes. Raw water would come in. Level transmitter was the full length of the vessel. An interesting feature of these, you could go to water cooling, where you'd flood a steam generator. Then the water from the steam generator would come back down the water-to-water header, and then you could feed into the dump condenser, then be pumped back to the steam generator through your condensate pump. So this would cool the reactor water down to ambient temperature for basically charge, discharge, and certain maintenance activities. Dump condensers had a vent system. There were 6 automatic vent valves. You had a 219 chain valve you'd open outside. And these HPV 218s, you could open them from the control room, vent the air off following maintenance activities. There's another line that come from 184 in the powerhouse. This come off underneath the storage tank of the generator. They had MWV 105 control valve for this. Then there's a check valve. So if the pressure in this header got less than the generator storage tank, which sat up quite a ways, it could feed water in here for emergency makeup. Other than that, it is kind of a complicated system, the different pressure controls, and the volume of water went through this. You know, it was pretty substantial. But I know we had to run 5 of the cells, or 10 steam generators on this system. And that's about it for Condensate 1. Okay, this is our slideshow of the Condensate 1. All we have is a couple drawings. If anybody has any pictures of this, we'd sure appreciate it. What I remember, these were the dump condensers. You had 16 of them that ran along the operating floor. You had your primary coolant steam turbine sat here, all 6 of them. The operator shack was between 3 and 4 steam turbine. Down the -16, all your dump condenser and condensate pumps, they ran along this direction. This was your primary coolant steam drive turbine condenser. Had your lube oil skid here for it. Condensate pumps sat back in here. And here was the access galley to the cells. You had basically drip lines to barrels to check any seal leakage off your pumps while you're running. Then you also had your level for your sumps. This is the steam generators. You had your steam collection manifold, and there's just 2 lines that come out of the steam generators up to the main steam header. I know working your 8-hour shifts, you had supposed to go in here 4 times a shift to check the sump levels and drippage. And then you had to go on the roof and look for leaks and problems and check the hydropacks 4 times a shift. So in the winter it might be 15 degrees up here and 104 or 5 down here. So Seems he got sick quite a lot. This here, they went down, the primary coolant piping went down to the sump. So this is kind of what we had to keep pumped out. But during shutdown, this was filled with water, kind of a barrier to keep the air from traveling through here, prevent. We had to keep a negative pressure back here on the reactor side. So the dump condensers ran along here. Your surge tank control header ran along up here. You had your 214s and 234s. We're back up in here that controlled the pressure for your surge tanks. And the next drawing, we threw on one of the dump condenser condensate pumps. We don't know the flow or the foot head rating of this. Can't find information on it, which is odd. But this is one of the basic pumps down there. There's 16 of them. This is the dump condenser. You had your 30-inch steam inlets. They went up here, hooked together, had this one line that went up to the roof. The air vents, these were used for startup to vent the air off. I believe the control room had could open these pneumatic valves up. We had a chain valve had opened to vent it off. Down here, temperature transmitters, measure inlet and outlet temperatures. A level transmitter across this to see how full it was. Like I say, they had about 7,380 square feet of tube surface. I think they're Admiralty metal, which is a copper nickel alloy. Noticed quite a few tube leaks. Had to go in here and plug tubes and do various maintenance. And this is kind of the main steam operating parameters. The plant was rated about 3.7 million pounds an hour. The operating temperature is 318 degrees and that was saturated. The main steam header ran about 135 or so. The drive turbines, 62.8, I think it was a little less than that normally. Supply system, they got whatever we gave them, somewhere around 135. And that's about it for this. If anybody has any pictures or anything, please share them. We don't really, all we have is just a few drawings. Anyhow, thank you. Have a good day.